In this video, we're going to learn about calculations regarding convex mirrors. Now, we are given with this mirror equation as 1L over F is equal to 1L over DO plus 1L over DI. If we're going to declare the following variables, DO stands for the object distance. Okay, this is the distance between the object that is placed in front of a convex mirror. So the distance between this object to this surface of this convex mirror is termed as DO. On the other hand, DI is the image distance. This is the distance between this image formed up until the back of the convex mirror. Then F stands for focal length. So this is the distance between point F up until this one. Now we have the magnification equation as m is equal to height of the image per height of the object, which is also equal to the negative value of the image distance per object distance. Now we have this sample problem as a 4 centimeter tall light bulb is placed a distance of 35.5 centimeter from a convex mirror having focal length of negative 12.2 centimeters. Now we are going to determine the image distance and the image size. Now remember from our previous video, if we are given with a value for the focal length as negative, automatically the analysis falls that this type of mirror is a convex one. For a negative focal length, it is always a convex mirror. Now let's declare the following variables. HO is at 4 centimeters. The object distance is at 35.5 centimeters, and the focal length is at negative 12.2 centimeters. I repeat, if we are given with a focal length that is negative, automatically it is a convex mirror. Now we are going to determine the image distance and the height of the image. Now let's proceed with the solution as we're going to use the mirror equation at 1 per F is equal to 1 per DO plus 1 per DI. Plugging in now the values gives us 1 per negative 12.2 centimeters is equal to 1 all over 35.5 centimeter plus 1 all over DI. Now, if we're going to further simplify the following fractions, this gives us negative 12, or I mean negative 0.0820 per centimeter is equal to 0.0282 per centimeter plus 1 per DI. Further simplifying the following quantities, if we're going to transpose 0.0282 to the other side of equation, this gives us negative 0.082 minus 0.0282 or negative 0.11 per centimeter is equal to 1 all over DI or the image distance. Further simplifying the following quantitative values gives us our DI now or the image distance is at negative 9.08 centimeters. Now let's proceed with solving for the height of the image. So we're going to use the magnification equation as HI per HO is equal to negative DI all over DO. Our HI now is all over with the height of image at 4 centimeter is equal to negative of the negative value of what we had got or solved for the image distance at negative 9.08 centimeter all over 35.5 centimeters. If we're going to cross multiply 4 to the other side of equation, this gives us with the following quantity as negative 4 centimeter times negative 9.08 centimeters all over 35.5 centimeters. Now, if we're going to solve for the height of the image, this is equal to 1.02 centimeters. The negative values for image distance indicate that the image is located behind the mirror. Now, on our next video, we're going to tackle about calculations regarding thin lens.